Okay, page 65. The elephant on the ramp. Draw a force diagram for the elephant. Okay, let's start by, as always, identifying our system. I draw my force diagram over here, my dot. Must have force of gravity on it. On elephant by Earth. The thing that's in my head is I know the net force on the elephant is 0 because it's just standing there on the ramp. So normal force is always normal, which means perpendicular. F normal on LE by ramp. And if it was just those two forces, like if I was to put those in my vector diagram, 1, 2, and label them, you'd see I'm not back to where I started from. So there'd be a net force there, and this elephant would be accelerating. That's not the case. So there must be another force. There must be friction. Friction always goes parallel to a surface. I can tell it's that big because I can see it's going to be this big in here. Force friction on elephant by ramp. The important thing on my vector addition diagram I'm going to add in before I move on to the next one is where the 90 degree is. The 90 degrees between these two, friction and go away. Friction and normal. So there's my friction on my normal. Between there's my 90 degrees. And my 20 degrees, if you watched a video, the quiz video, I think it was, I can't remember if it's today's quiz video or tomorrow's quiz video, I talk about how to identify where this is. One way you can do it is to make another triangle at a really, really shallow angle and draw the force diagram for that and make that into a vector addition diagram with a really shallow angle. If there's a really shallow angle, the normal is hardly any angle at all. Let's say that was 3 degrees. Where's the 3 degrees on here? Which is the really small angle on this triangle? This bottom one's a really small angle. So that's the 3 degrees. So the process of me doing a very shallow triangle helps me to figure out where this small angle is. This is now the same process here. This is the 20 degrees in here. Okay, 3C. You calculate the friction force on the elephant. I'm going to now use this triangle I've drawn, so I'm going to redraw it. It's meant to be straight down, but I'm just terrible. FG, F normal, F friction. This was 90 degrees. This was 20 degrees. But it's a triangle. It's a triangle that can help me work out this guy here. I know one of these sides. I know FG. I know the force of gravity. I can work it out because the elephant's mass is 2,000 kgs. And the force of gravity is always 2,000 kgs times 9.8 newtons for every kg. This gives me, on my calculator, 2,000 times 9.8, 19,600 newtons. So that's what that is. So I'm going to redraw my triangle with the things I care about, so it's just less cluttered. Here's my 90. I need to find friction. I now know that this side of my triangle is this big. I know this is 20 degrees. I'm not going to worry about the other side because I don't really care about it at the moment. That's meant to be a 0. It just didn't look like it. Okay, so now I'm going to do some SOHCAHTOA. This is why we practice them so often, because now they're coming up. First of all, with my right angle, that can help me. The opposite of that is the hypotenuse. It's also the longest one. This is my angle, so this is adjacent to the angle, and this is opposite the angle. So what do I care about? I care about these ones. So I'm going to have SOHCAHTOA. I've got the opposite and the hypotenuse. So sine 20 equals opposite, force of friction over hypotenuse, times both sides by this, and I get 19,600 times sine 20 equals my force of friction. And if I do that on my calculator, times sine 20 equals 6,703.6 newtons. And my answer here says 6,700 newtons to SF. The last video I said that SF means significant figures. So this is in two significant figures. And I'm going to make a separate video, but here's a real short story is that generally in level 2 you have two significant figures, but we'll talk about why soon. But this is one significant figure, 2, 3, 4, 5. So two significant figures is there, and everything else is just rounded off. And if I've done that, then I should write that I've done it. We'll talk about this idea of significant figures and when we're going to need to use it in a separate 3 or 4 minute video at the beginning of next lesson. Okay?